NASA's Voyager 2 spacecraft has been sent back its first message from interstellar space.
Voyager 2, launched in 1977, has been traveling through the outer reaches of our solar system for nearly 5 decades. In that time, it has witnessed and recorded some of the most profound and mysterious phenomena ever observed in space. Most recently, it reached the very edge of our solar system, a boundary known as the heliopause, a vast, invisible curtain where the solar wind, a stream of charged particles constantly emitted by the sun, is finally halted by the interstellar medium. What Voyager 2 just saw at this boundary is reshaping our understanding of the solar system and the forces that govern it. Before we start, smash the like and subscribe buttons for more updates. As Voyager 2 approached the heliopause, the data it transmitted back to Earth revealed a turbulent, compressed region unlike any previously theorized. The spacecraft encountered a sudden and dramatic increase in cosmic rays, high-energy particles originating from outside our solar system, indicating it was crossing into a space dominated more by the galaxy than by the sun. This transition marked the moment when Voyager 2 entered interstellar space, making it the second human-made object to do so after its twin, Voyager 1. But unlike its predecessor, which had a somewhat different trajectory and less functional instrumentation at that distance, Voyager 2 offered a far richer stream of data as it crossed this frontier. The most astonishing revelation came from its plasma wave instrument, which measured changes in the density of charged particles. As it moved past the heliopause, the probe detected a jump in plasma density, confirming that it had left the sun's protective bubble and entered a region filled with the plasma of interstellar origin. This sudden change contradicted previous assumptions that the transition would be gradual and highlighted the existence of a sharply defined boundary between solar and interstellar environments. Voyager 2's instruments also recorded a significant drop in temperature and velocity of the solar wind particles just before the spacecraft crossed into interstellar space. This unexpected phenomenon suggests that the heliopause acts as a kind of cosmic pressure cooker, where particles are slowed, compressed, and heated before escaping. The implication is that the sun's influence, even at its farthest reach, still exerts a dramatic effect on how energy and matter interact with the galaxy beyond. One of the most profound observations was the orientation of the magnetic field. Voyager 2 discovered that the magnetic field in interstellar space is strikingly different in direction from the one carried by the solar wind. This discrepancy indicates that the heliopause is more than a simple boundary. It is a dynamic, twisting interface where competing forces clash. It's as if the solar system is enveloped in a constantly shifting magnetic cocoon, molded by the sun from the inside and the galaxy from the outside. Voyager 2's journey through this field has exposed its complexity, with distortions and tensions that could influence how cosmic rays penetrate the inner solar system. There was also something deeply unexpected. Voyager 2 recorded low-frequency plasma oscillation, signatures of events occurring beyond the heliopause. These are believed to be echoes of interstellar shockwaves, perhaps originating from ancient supernovae or large-scale galactic turbulence. That the spacecraft could detect such distant signals reveals how interconnected our solar system is with the larger galaxy, even at a distance of more than 11 billion miles from Earth. It suggests a universe much more acoustically alive than previously imagined. Equally fascinating was the discovery that the outermost region of the heliosphere, the heliosheath, is far thinner and more structured than models had predicted. Voyager 2 passed through it in a matter of months rather than years. The data revealed strange eddies and layers, as if the solar system's boundary is not a uniform shell but a wrinkled, folding skin that shifts depending on solar activity. This complex layering could serve as both a shield and a sieve for galactic radiation, influencing everything from space weather near Earth to the habitability of planets. While the heliopause was long theorized to be the solar system's edge, Voyager 2's crossing made it abundantly clear that this boundary is not fixed. The sun's magnetic activity waxes and wanes in 11-year cycles, and with it, the size and shape of the heliosphere fluctuate. Voyager 2's instruments detected evidence that the heliopause breathes, pulsing in response to the solar cycle, expanding and contracting like a living organism. This breathing heliosphere could mean that some parts of our solar system are periodically exposed to more interstellar radiation than others. a factor that could influence long-term climate and evolutionary processes on Earth and other planets. What Voyager 2 saw was not merely the end of the solar system as a defined edge, but the beginning of something more intricate, a dynamic frontier that reacts to both internal and external cosmic forces. The boundary is more like a shoreline than a wall, a place of mixing and transformation. Charged particles from the sun and interstellar medium collide here, exchanging energy and altering trajectories in unpredictable ways. In this churning region, shockwaves can form, magnetic fields can twist and reconnect, and particles can be accelerated to nearly the speed of light. The spacecraft's crossing also offered new insights into the nature of cosmic rays. As Voyager 2 moved beyond the heliopause, it encountered a steady, omnipresent flow of high-energy particles. Without the sun's magnetic field to deflect them, these galactic cosmic rays streamed in unimpeded, providing direct measurements that could never be made from within the heliosphere. Scientists observed not only their intensity but also their composition and direction, gaining clues to the violent processes that produce them, such as exploding stars and black hole jets. This opens up the possibility of using future spacecraft to map the energetic landscape of the galaxy in greater detail. At the same time, Voyager 2 detected a region just beyond the heliopause that seemed unusually calm and quiet in radio emissions. This interstellar silence contradicted expectations of a noisy, turbulent galactic environment. The silence could mean that the spacecraft had entered a rarefied region of space or a temporary void, raising questions about the structure of the local interstellar cloud through which our solar system currently travels. It challenges assumptions about the uniformity of interstellar space and suggests there may be vast, ghostly regions between stars that remain undisturbed for millennia. Another startling observation involved the solar system's tail. Voyager 2 passed through part of what is thought to be the trailing end of the heliosphere, revealing that this tail is not smooth or consistent. Instead, it appears to be warped, twisted, and riddled with bubbles of trapped magnetic energy. These magnetic bubbles might be pockets of solar influence that have broken off and drifted into interstellar space, still holding remnants of the sun's magnetic fingerprint. Their existence implies a solar legacy that extends far beyond the sun's physical reach, scattered across light years of galactic space. Voyager 2's approach to the heliopause also provided a rare look at how the solar wind evolves as it slows down and interacts with the interstellar medium. Measurements showed that the wind doesn't simply taper off, but becomes chaotic and turbulent. The spacecraft recorded wave-like fluctuations and regions of reversed flow, like eddies in a river. This turbulence could play a crucial role in shaping the heliosphere, dispersing solar particles in unexpected directions and influencing the overall balance of pressure at the boundary. Perhaps most compelling of all was the glimpse Voyager 2 gave us into the larger galactic environment in which our solar system is embedded. Beyond the heliopause, space is not empty. It is filled with the faint whispers of stars, the drifting remains of exploded suns, and the subtle pressures of magnetic fields that stretch for hundreds of light years. Voyager 2 is now swimming in this vast ocean, and its sensors are acting as our eyes and ears in a realm untouched by any other probe. The implications of these observations are far-reaching. They reshape our models of how the solar system interacts with the galaxy, influence our understanding of space weather, and challenge assumptions about the boundaries of planetary protection. By showing that the heliosphere is a fragile, shifting membrane, Voyager 2 emphasizes the vulnerability of our planetary system to forces from the outside. It also suggests that the sun's influence is both more limited and more dynamic than once believed. Voyager 2's crossing also has profound implications for the future of interstellar exploration. If the heliopause is more permeable and variable than expected, then future probes designed to leave the solar system must account for a more chaotic transition zone. Navigation, communication, and instrumentation will need to be robust enough to handle abrupt changes in particle density, magnetic orientation, and energy levels. Understanding this boundary is no longer just a theoretical pursuit, it's a prerequisite for safely venturing into interstellar space. And what Voyager 2 saw adds a new dimension to our understanding of cosmic boundaries. For centuries, humans imagined the edge of the solar system as a fixed perimeter, a kind of celestial fence. But the data from Voyager 2 reveals that the edge is more like a storm front, shifting, dynamic, and alive with unseen currents. The spacecraft has shown that space is not a static backdrop, but a constantly evolving interplay of forces, energies, and matter. Every particle it encounters tells a story, not just of the sun, but of the galaxy itself. Even as Voyager 2 continues its journey outward, Its encounter with the heliopause stands as one of the most significant moments in space exploration. It has uncovered a boundary more complex and beautiful than we ever imagined. Layered, turbulent, and permeable. A boundary that is less a line and more a realm, where the sun and the galaxy meet in a constant dance of energy and magnetism. What it saw there reminds us that the solar system is not an island, but a ship sailing through a vast and mysterious sea, and Voyager 2 is our lone scout at the bow, peering into the deep unknown. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Voyager 2's discovery? What do you think it saw? We want to hear from you. Thank you for watching, and see you next time.